And now we come to the next topic, but this topic, electrical conductivity, is of the topic quality of water. Okay, so electrical conductivity, we have seen the formula CS is equals to CQ upon Q minus CU minus PEF. तो PEF क्या था? इफेक्टिव रेनफॉल था. CU क्या था? दिस इज द कंजम्पटिव यूज. ओके, एंड रिमेंबर, critical salt concentration in water should be greater than 700 ppm. It should be greater than 700 ppm. No, remember, critical salt water in water, if it is less than 700 ppm, then it is useful for all the crops, and if it is greater than 700 ppm, then it is harmful for the crops only. Okay, harmful for some crops, but if it is greater than 2000 ppm, then it is harmful for all the crops. We should not use the water if its ppm is 2000, more than 2000, or greater than 700 ppm for certain crops, and for all crops greater than 2000 ppm. First is critical conductivity. What does critical conductivity? The name even it suggests that conductivity of electricity in the water which we are supplying to irrigate. Okay, so what is electrical conductivity? It represents concentration of salt in water. This directly means that salt concentration is directly proportional to electrical conductivity, and its units is micro second per centimeter. Remember the units of electrical conductivity. Electrical conductivity is measured in second per centimeter. Okay, now there are some standard values. If it is less than 250, then it is low salinity. If 250, 750, then medium. 750 to 2250, then it is high salinity water. And if it is greater than 2250, then it is very high salinity water. Remember, last time we have studied about this low, medium, high and very high. Similarly, for electrical conductivity, it is also similar. And for low salinity water, it can be used for all crops. Low salinity water is good for all crops. Medium salinity waters, if we have to perform leaching, a process which I told you, in which we add water to the salts, and water salts get dissolved in the water, and then we suck the water out. First we waterlog, then we pump out the waterlogged water when salt gets dissolved in it. This is one way of treating this medium water. And third is high salinity water, used for only very high tolerant crops. So therefore used for plants having high tolerant power. And greater than 20 to 50 ppm, it is very high salinity water, and it is not suitable for any of the crops to be grown. Okay, this was an important topic of quality of water which we have studied just now. Okay, this is a topic of quality of water. Let's see some numericals. One numerical is directly, first we have to find out the water distribution efficiency, which we have discussed yesterday, that percolation is most in the left corner and least in the right corner. So there was a numerical which I told you about efficiencies. Solve this numerical, and this is solved. I have solved this numerical for you. First, if it is not given in the order, then you have to convert it in the order of increasing order, descending one. Okay, so 2, 1.93, 1.85, 1.55, 1.45 and 1.22. These are the values. We have to represent it in that triangle shaped percolation chart. Okay, then find out the first capital D, and this formula was 1 minus small d upon capital D into 100. Remember this formula? 1 marks question will definitely come from this part, water distribution efficiency. For first capital D we have calculated 1.663. Now I have told you this 1.663 will be subtracted from 2 one time. One value will be given 0.337 for small d calculation. See small d calculation, 2 minus 1.663, it will give you 0.337, and then 1.93 minus 1.663 will give you 0.267, and so on to last 1.2, it will give you minus 0.463, but minus is to be neglected. We will take absolute values and add them and then get the average, that is small d. Now put it in the formula of water distribution efficiency, 1 minus small d upon capital D into 100, you will get 84%, 0.919%, exactly. Check it out. Now this is one question. This is one question which is based on your delta value, and we have to relate delta value, period, time period and area of that crop. Okay, so I have done it for you. Duty of the crops 1, duty of the crop 2 will be related when it will be in the ratio d1 upon d2, then their value will be converted into hectares, and hectare is a unit of area, therefore area can be related. So in this question you have been asked to find out the second area of second crop which is being irrigated by this much delta of water. A1 A2, you will get A2, the value of A2 will be 319.09. Conversion should be correct. Okay.